Ladies and gentlemen, boys and girls, children of all ages. All right, we're obviously working on our division unit. Yesterday on the Book of Face, I posted a couple different videos for when we get to dividing with decimals, because you're going to have to recognize how to do models when we divide with decimals. Not doing that yet. Dividing with decimals is really pretty easy. In fact, those of you that have been working on the restaurant bill activity have already probably will recognize the problem $72.35 divided by 5.
Yep. Yep. I don't know how, but yeah.
If you remember on that restaurant bill activity, you had 5 people. They ate. They were going to split the bill equally. And with the tip, it was a total of $72.35. So you had to add the bill, and then you had to add the $12 tip, and all that stuff up. Now for this, y'all know your multiples of 5, but just for practice, because I know some of y'all's parents forget how to do 5th grade math, so it's a lot of what these videos are for is for parents. I mean, because honestly, how many of you have gotten home and your parents are like, I don't know how to do that? Yeah, see, hands you. I know your mom, Chloe. Chloe's mom's like, count past 10. I teach kindergarten. I don't go past 10. Right? So one of the strategies that we've talked about is our multiples of our divisor. Again, 5 is our divisor. So if we list our multiples of our divisor, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. Everybody's writing this down, I'm sure. 5 times 4 is 20. Especially because I know those of you that have done your restaurant bill can be able to check it. Those of you that haven't done are going to have one of the first answers for you here. Yeah, it is. Okay, so we always, I'm not going to say you always, but it's a good habit for you to get into to write down your multiples, your first 9 multiples of your divisor. Makes your life much easier. Now when we're dividing by decimals, if you have a decimal point in the dividend, the decimal point comes straight up. It's up. I need it in my quotient. Now I'm done with it. Once you move something, it's not where it was before, right?
Oh, right. Yeah.
So, if I have Natalie's drink and I move it, her drink is not where it was before. My decimal point was here, I'm moving it, it's up here. I don't need to do any of this so many times. Even after I say, I'm going to see people moving that decimal point down here, and people were trying to do it yesterday and drove me crazier. Now, the first couple of times we've talked about division, I've been very specific on where the number goes in the quotient. Very specific on where the number goes in the quotient. Izzy,
Yes.
Is 5 going to go into 7?
Yeah.
Yes. Means I'm going to have 2 digits in front of my decimal point and 2 digits behind my decimal point. Now, if this were a multiple choice problem, already right now I probably could have eliminated some answers. I haven't had to do any math. All I just have to figure out is where my divisor goes into my dividend. I know it's going to go into 7, so that means I need to have a number above the 7, above the 2, above the 3, and above the 5. Where you write your numbers in your quotient are very important. Very important. JJ, how many? Looking at our multiple list over here, JJ. I need a multiple of 5 that is as close to 7 as I can get without going over. 5 times 1, which is 5. And then I subtract. Okay, now I know that I'm going to have less than 20 as my answer. I've already decided that. Because I got a 1 in the tens place. So my quotient is going to be less than 20. You getting this written down?
Yes.
My quotient is going to be less than 20. I already know that. Smart that way. I know my quotient's going to be less than 20. After I subtract, then I bring down, and now I'm taking 5 into 22. So I go over here, Sanaya. I look at my multiples of 5. Which one is as close to 22 as I can get without going over? 20. And that would be 5 times 4. So now I know my quotient is going to be less than 15. It's going to be 14 and something hundredths. In the case of the restaurant problem, it's actually dollars and cents. Then we do 5 times 4, which is 20. So I was talking to this teacher yesterday, and she's like, they'll do a division problem with 1-digit divisors, and they'll knock it out of the park. And then I throw a 2-digit divisor problem at them, and they'll go like, I don't know how to divide. Like, but you just... I said, well, just have them write this down. And she goes, my gosh. Her kids are so much better at it after she had them write them down. I'm just saying. Oh, it ain't me. It's all you guys. It's all you guys. All right, so now we have brought down our 3 from our dividend. And we say, Kane, you're not putting the numbers up here in your, you can't just, you got to put your numbers in your quotient, because that's what we're looking to find. So, Morgan, I need to look here. I need to find a multiple of 5 that is close to 23 without going over. 20. So I'm at 4 again. So now I know I have a 4 in my 10th place. A 4 in my 10th place. And then I subtract. I still have one more number to bring down. As long as I have a number to bring down, I got to bring it down. Every number I bring down is going to have a number above it in the dividend, in the quotient. Now. Jaron. I look here, and I need to take 5 into 35. I need to find a multiple of 5 that is closest to 35 without going over, and it is? 7. Because 5 times 7 is 35.
Are you Jaron? Yes, so.
I have nothing to bring down. Nothing to bring down. Colin, how do I say this number correctly like you're a 5th grader, not a 2nd grader?
14 and 47 hundredths.
14 and 47 hundredths. 14 and 47 hundredths. Natalie, what is the inverse operation of division?
What? Multiplication.
Multiplication. We can you guys stop? Y'all fighting like your brothers and sisters all the time. Mom likes you best. No, Mom likes you best.
Natalie.
Well, you answered when I called Natalie.
So.
All right, so as Natalie pointed out, we're going to use our inverse operation to check. I should be able to multiply my quotient times my divisor, and that should give me my dividend. So 14 and 47 hundredths times 5 should give me 72 and 35 hundredths. 3 times 5 is 5. 3, 23, 3, 3, 2, 2, 22, 2, 2, 5, 6, 7. Boom!
Oh my god.
Worked. It worked.
I'm already.
It worked.
That's what I do.
So that's an easy with the one-digit divisor. Process is the same if there's a 78-digit divisor. It doesn't matter. Well, yes? Yes, Kason, you can see one with a 2-digit divisor.
He didn't.
No, he did. I heard him. I heard him ask.
He's quiet.
We have this psychic connection.
Psycho connection.
I meant psycho. I meant psychic connection.
Psycho connection. He's trying to hide something.
Now, this is a problem you might see in an assignment next week.
Oh.
Yeah, next week into the future, yes.
Whoa.
So you're going to solve this, but the first thing you're going to do when you solve it is you're going to list your multiples of 13.
Seriously? I don't know.
I will pause.
I don't know what they're talking.
All right, and we're back. Mason, how many numbers are going to be in front of my decimal point in my quotient? 2. Okay? So you're going to have a number above the 9 and a number above the 7. How many times does 13 go into 9? So you're not going to have a number above the 9.
My teacher's talking.
No, so you're not going to have 2 digits in front of the decimal point. Okay. So I'm going to have 1 above the 7, 1 above the 6, and 1 above the 3. So now, Mason, I look at my multiples of 13 over here. I need to find, you said it's going to go into 97. I need to find a multiple of 13 closest to 97 without going over.
7.
13 times 7 is 91. Mason, 91 or 97 subtract 91 is 6. So I have the 6 and I bring down the next number. My next number is going to go in the 10th place. JJ, how many times is 13 going to go into 66? 5 times. And JJ, what is 13 times 5? 65. Bring down my next number. It's going to go in my 100th place. Next number is going to go in my 100th place. Chloe, I need to find a multiple of 13 that is as close to I can get a 13 without going over. The first one, 13 times 1 is 13. If we list the multiples, the problem pretty much does itself. Once you list the multiples, the problem pretty much just does it. You have to do a little bit of subtracting, but beyond that, you have to be willing to do it. But beyond that, it's really fairly simple. Boom, shakalaka, peace out, God bless, love ya, do something kind today.